What if I told you I could measure the tallest building in Hong Kong, which is somewhere over there, without ever stepping inside it? To do that, I'm going to need a clinometer, which is one of these, but I don't have one of those, so I'm going to have to make one. So let's make a clinometer together. So as you saw from what it looks like, a clinometer measures angles, and so I have a protractor, but I'm going to need some string. So I just got some string at my local supermarket, and I'll need a straw to look through it as well. All right, so I went ahead and bought some straws, but paper straws, because save the turtles, and I have my string here. So the way that this is going to work is I'm going to look through the straw while I measure the angle, and then the string is going to hold a counterweight so that it's steady. And then hopefully I can measure the tallest building in Hong Kong. Let's go! And I think we're quite lucky because here's my boat. It's just arriving now. So this is the Discovery Bay ferry, and it takes about 20 minutes to get to central Hong Kong from here, taking this boat. I'm gonna get on board now and we'll make the clinometer on the boat, and then we'll go and measure the building. Join me on this boat ride then. As we leave Discovery Bay, we beep our way through the gates using our telephone and what we call an octopus card here. Find myself a nice little spot on the boat, and we will pull away from DB on the ferry. You can see some shots of the waters as we leave here, and I'm left with a protractor which I will tie up to a straw, so they're together with some tape, and I'll put a piece of string through the whole thing, and the battery will act like a counterweight, so that will allow me to measure the angle. Yay! Now, if you've never been to Hong Kong, let me take you for a quick tour. This is my city and I love living here. Let's go. Hong Kong is a vibrant, exciting, safe and diverse in culture kind of city. It's got amazing tramways, beautiful foods and lots to offer. If you ever come here, you can walk around any part of the city and I'm sure you'll enjoy the art and the resounding vibrancy of all the colors here. You can find temples in the middle of bustling streets. But it's not just buildings and skyscrapers. You also have an amazing amount of greenery all around Hong Kong. Now, of course, Hong Kong wouldn't be Hong Kong without the buildings and the shopping malls, which are incredible in terms of architecture, with all the most expensive shops you could think about in the world. Beautiful boats by night, like this traditional junk here, and Hong Kong is separated by Victoria Harbour, which you can see. And on the edges of Victoria Harbour you have IFC and ICC, like in Lord of the Rings, these amazingly big towers just opposing each other. Now the theme for today is we're measuring the tallest one, and ICC pips IFC by just a little bit, so let's get back to the video and measure ICC. Okay, so here we are. There you have it. There is the tallest building in Hong Kong, and we're going to go ahead and we're going to measure it. Alright, now is the math portion of the video. We do need trigonometry, which is the measure of triangles, and when you have a right angle triangle, you can either find the sine of the angle, which is the opposite side, divided by the hypotenuse, or the cosine, which is adjacent over hypotenuse, or the tangent of the angle, which is the opposite side over the adjacent side. Now, we talk about these in right angle triangles, and most importantly, we refer to the angle A. So opposite to the angle A will be the side BC, and adjacent to angle A next to will be the side AC. Now, let's take an example here, imagining that we are looking at a tree, and we have the distance to the base of the tree, and we might be able to measure the angle of elevation with a clinometer, like we're doing here, to the top of the tree. Of course, flying to the top of the tree is difficult, so finding the hypotenuse in our triangle is quite difficult. But we could definitely find the distance to the base of the tree and the angle, which would help us, using one of those trig ratios, to find the height of the tree. Now, since we are working with the opposite side to the angle and the adjacent side to the angle, we'll need to figure out which one of the three ratios we have to use. And so if we look back at our formulas, the sine was the opposite over hypotenuse, cow was adjacent, the cosine was the adjacent over the hypotenuse, and the tangent was the opposite over the adjacent. So we need tangent. This is the ratio we're going to use. So here are the things we need. We need the angle, the distance to the object, and a calculator. So for the angle, we will use a clinometer, which is the measuring device that we made on the boat. For the distance to the object, well, I'm just going to use my iPhone and rely on Google Maps. And a calculator, well, we all have one of these, so no worries there at all. Okay, so now that you know the trigonometry behind it, it's time to measure it. Okay, so we're ready to go. I have my clinometer here, and even though I might look like a little bit of a goofball, I'm going to go ahead and try and measure ICC using this makeshift device. Let's try it out. So I'm trying to look through the straw here, and even though I get a good shot of the top of the building, it's a little bit difficult to see what the degree measurement looks like. Okay, so it looks to be about 75 when I look at it here. There's a little, I don't know if you can see this on camera. Ugh. Looks to be about 75, but that is not going to be my angle of elevation to the top of the building. In fact, it's going to be what we call the complementary angle to 75, which is 15. 75 plus 15 adds up to 90. And so I think 15 is going to be about right. I got 75, 76, 74. I'm going to say 75 is as good as I can get it here with a device as kind of inaccurate but kind of cool as the one I made today. So let's go with that. 75 degrees, 15 degrees for my angle of elevation, and let's see how high the building is. Now I do need one more thing, which is the distance to the bottom of the building. And so for this, I'll use the measuring tool, which I've pulled up here from Google Maps. And it pulls up my location, and you get a straight bird's eye view distance to the bottom of the building, which is 1,762 meters at the bottom of your screen. All right, welcome to Mathemagic HQ. In other words, my house. If you've made it this far in the video, you probably want to know the height of ICC, so let's go ahead and find out. So I've made a little drawing for you so we can have a nice clear reveal here. The height of ICC, I've labeled H. The distance to the base of ICC is 1,762 meters as per Google Maps. The angle of elevation was 15 degrees. Okay, so we've said we're going to use tangent. Now, tangent is the relationship or the ratio, percentage, between the opposite side and the adjacent side. Simply put, if the opposite side is super big, you expect this angle to be super big as well. And the percentage would be a little bit bigger of the opposite side against the adjacent side. If the opposite side is quite small, the angle is going to be quite narrow. Like in this case, the angle is pretty narrow. And so the ratio between the opposite side and the adjacent side is going to be pretty small as a percentage. Now, we have the angle, we have the distance, and we're looking for the height. So we're going to set up our equation. So we do have to do a little bit of mathematics. So here we go. The tangent of 15 degrees, so it has to be the tangent of an angle, in this case 15 degrees, is equal to the opposite side, the height, so I'm going to call that h, divided by the adjacent side, 1,762. Now, in mathematics, when you want to move things from side to side, you follow algebra rules. Divide becomes times. So if I move the 1,762 to the left, it'll become times. So 1,762 times the tangent of 15 degrees, that is going to be equal to the height of ICC. Now I'm going to take my trusted calculator and plug this in right now for you. Now, I don't know if you can see this, but it says 472. Now, I'm going to keep it to the nearest meter, about 472. So the height of ICC is about 472 meters tall. Now, let's not forget that I have a little bit of a height myself. I'm 1.7 meters tall, roughly. I'm going to round it up to 2 meters and say the height of ICC is approximately equal to, so I'm going to say approximately equal to 474 meters tall. So this is my final answer, 474 meters. Now, before we hit the reveal button, I want you to consider the fact that I didn't have to fly to the top of ICC. We didn't have to use a pile of rulers to measure each floor length. And all we had is this flimsy little protractor and a battery and an angle of elevation. Now, for the reveal, the actual height of ICC is 484 meters. So I was off by 10 meters, which is pretty good considering this is all I had to go with. So that's absolutely amazing. I'm super stoked, super happy with the results, you guys. That's very, very good. Awesome. Thank you for watching the Mathemagic channel today. I hope you enjoyed this video. I hope you enjoyed watching it as much as I enjoyed making it. It's just to show you the amazing applications of mathematics in real life when you can have some very simple objects, but some really good formulas that can help you. Until next time, please make sure you like and subscribe to the Mathemagic channel so we can bring you more amazing math videos. Thank you so much. See you next time.